Oh my gosh, it's good to go. Oh my gosh. It's alive! Hey there, home labbers, self-hosters, IT pros, and engineers. Rich here. Sometimes a fleeting thought like the one in my Minis Forum Nab9 Plus video will send my mind spinning in directions that I just can't shake until I do it. In that video, I made this comment. However, I could see the value of hanging a RAID card off of it and connecting that to an external storage array for more storage. Maybe something for a later video. So that's what we're gonna do in this video. Here's the plan. I'm gonna bring you along with me as I source the parts, get them connected, install TrueNAS Community, test it all out, and then build and design a 3D printed enclosure for this cursed network-attached storage system that I've dubbed FrankenNAS. Let's get started. Every good DIY project starts with a list, right? Here's the parts I think I'm gonna need to pull this off. First off, we're gonna need the Nab9 Plus, which we already have. Next, we're gonna need to obtain a RAID card, since that's the point of this video. We're obviously gonna need an OcuLink to PCI Express board to connect the RAID card into, and we're gonna need an OcuLink cable. We're gonna need some sort of drive cage or backplane to hold our drives, preferably 12 gigabit SAS, cause I'm overkill like that. And of course, we're gonna need mini SAS cables to connect everything together. Oh, and lastly, we're gonna need some sort of power source like a PSU to power the OcuLink board, RAID card, and array. Let's see what we can find. Just as a recap, the computer playing the central role in our cursed FrankenNAS is the Minis Forum Nab9 Plus. I did a video for this little guy a few weeks back and felt like it was perfect for a little starter home lab. And with the OcuLink port in the back of the unit, it's got all we need to be the heart of our FrankenNAS. Check out the video we did on this system if you're looking for a starter home lab server. It's great for that. Now it's time to find our RAID card, and that means it's a perfect time to head over to every home labber's favorite addiction website, eBay. Searching eBay for a RAID card provides more results than a mere mortal could possibly handle, and I have some specific features I want, like making sure the RAID card can support SAS3, which offers 12 gigabits per lane. In the end, I settled on this guy here, a Supermicro AOC S3108L H8IR 8-port 12 gigabit SAS3 PCIe RAID card. I like this card for a few reasons. 1, cheap as hell, $30 in free shipping, you can't beat that. 2, it's a SAS3 card, so if I wanted to, I could throw some serious enterprise SSDs in it. And 3, the model number clearly says H8IR or Hater, and I feel like that's fitting for the FrankenNAS. RAID card sorted, onto the OcuLink to PCIe board. Back to the eBays, I started searching for an OcuLink to PCIe interface board that would suit my needs and found this one here. I liked it for a bunch of reasons, but here's the thing. I didn't actually end up buying this one because the seller absolutely wouldn't negotiate on the price with me, which isn't a bad thing because that led me to find an even better option on Amazon. This guy here is ultimately what I ended up buying. Here's why I like it. First off, it's cheap at around $22 US, which, compared to the nearly $80 from the eBay seller, is a steal. It's also a big flat card with mounting holes that will make mounting it into an enclosure easy. It's also got a 24-pin ATX power connector directly on the board and a little power switch right here that allows me to control the power of the PSU. It's perfect. Now that we have our OcuLink to PCIe board, naturally we need an OcuLink cable. I'll save you the drama. This was the best deal I could find for an SFF8611 to SFF8611 OcuLink data cable, coming in at $21 US. There's nothing much more to say about this than that. It's a data cable, it was cheap-ish, and Amazon had it next day. Here's an ultra close-up of the interfaces on the cable. They look like high-density DisplayPort connectors with their little notched corners. Now let's figure out the disk array. In my mind's eye, I'm hoping to find a complete modular disk cage that has everything, like the actual metal cage, the backplane with interfaces and power, and of course disk caddies as well. Oh, and it also has to support SAS3 since the RAID card does, so I headed back to eBay to hunt for just the right part. It's wild to me that you can just search for something like disk array backplane on eBay and find options. In my searching, I came across a lot of options, which was awesome. Most, like this HPE disk array, had proprietary interfaces on them, which wouldn't help me since I needed standard mini SAS to mini SAS connections. But after some patience and some further digging, I found this guy here, the Chenbro RM35206 3U 6-bay 2.5-inch cage. At $48 US, it was a steal. It's got basically all the things I could ask for. It has 6 total bays, 4 of which are SAS 3 via mini SAS and 2 of which are standard SATA, is powered by 2 standard 4-pin Molex connectors, and has the entire cage and toolless disc caddies to make life easier. Bonus points for being a good color combination as well. I've never touched anything made by Chenbro before, but I do like the fact they have the word bro in their name, and it goes well with our hater raid card, doesn't it? Now let's get some mini SAS cables. Back to Amazon because buying cables anywhere else is just a waste of money. Again, I won't belabor the cable search or purchase, so here's what I ended up buying. First, on the mini SAS to mini SAS front, I bought this guy here, the 10G-Tech SFF8643 to SFF8643 12GB internal mini SAS HD cable. This will connect the 4 SAS drives on the cage, and it was cheap at a little over $9 US to my door. And for the mini SAS to SATA cable, I bought this guy here, an SFF8643 to SATA breakout cable for $10.50 US. This will give me the last 2 disk interfaces on the array and leaves me with another 2 spare SATA ports if the need arises. These 2 cables will connect the hater RAID card to the bro cage, making it either a hater bro or a bro hater. Anyway, this completes the entire storage setup. We have one last thing we need to source and buy though, and that is a power supply, because this thing needs its own dedicated power. My immediate thought here was to go for a smaller PSU like an SFX power supply over a standard full ATX power supply to save on space. I also really want a modular power supply because I really only need the ATX and Molex power cables to power everything, and having a bundle of everything hanging out the back of the PSU is a mess I don't want to deal with. Off to Amazon to see what we can find. My big fear looking for a small form factor PSU like an SFX was that they tend to have a higher price tag attached to them than an ATX PSU, especially when throwing in modular power cables as well, and at first, that's what I was finding. Modular SFX power supplies from the bigger name companies were expensive, and there was no way I was going to entertain putting that much money into a PSU for FrankenNAS. Thankfully, my perseverance paid off because I found this guy here, the 650-watt GameMax GS Series SFX power supply. Have I ever heard of GameMax before? Nope. Is 650 watts way too much power for the cursed NAS? Yep. Would I put this PSU in any legit computer build I was building? Not a chance. It's absolutely perfect for this project. Oh yeah, and at $80, it's palatable. Hit me up in the comments if you have a different suggestion on what power supply I should have used. We have everything we need now to build our cursed FrankenNAS. Before I design an enclosure though, I think it's best to just plug everything together and check to make sure it works as I hope. This would be a fantastic time for you to subscribe to this channel, especially if you enjoy home labbing, self-hosting, and poorly thought through tech DIY projects like this one. Also, join in the conversation on our Discord server while you're at it. It's entirely free and a great place to hang out with other home labbing nerds like you and me. All right, let's get everything connected together, see if it all works, and if it does, throw TrueNAS Community on it.
Plug in the Oculink cable. The maze form, it plugs down here, upside down, and this guy here plugs in that. Okay, there's one. Next, power supply, just the ATX. One part, other part. Now I got this big hunkin' ATX power cable, which we're gonna go and take, plug right here. Join right there, we go. Boom, I gotta get the RAID card plugged in. Take this guy. So, okay. We're gonna use these guys here. These crucials that I've had for a long time. This whole thing, and just like move it out of the way to the side. These are toolless, which is awesome. So they just like slip in, just click into place. One, two, three, four, five, and finally, number 6. Let's get our Chenbro back here. 1, 2, 3, 4, 5. Now let's get them all plugged in. So we'll take our 2 cables there, Click. This guy here. Goes right here like this. Click. This guy, the mini SAS to SATAs. Spot like so. Click. And we're going to need P1 and P2. So why not? Take those guys. Click. And click. Cool. Last thing to do here for physical setup testing is the power for the array. Plug in right there like that. Take this duder. Get in the fast one. And then this one right here. And we're ready.
Entirely built and ready for first boot. Let's do this. First things first, let's turn on the power supply, which will power up the PCI Express RAID card. Let's do that. Get all the lights on the array. Look at that. Now, let's turn on the NAB 9 Plus and boot off of the USB stick. The light's flashing! It's so crazy! Oh my gosh, it's so awesome. Okay, we're gonna go boot off of this guy. I'm not going to how-to you through the install of TrueNAS Community. I just want to get the system up and ready so we can test it out and build out the box. Needless to say, the installation went as expected with no issues to report, and yes, TrueNAS saw all of the drives, which is awesome. Let's jump over to the UI of TrueNAS and get to some testing. Welcome to TrueNAS Community on the FrankenNAS. Let's run through what and how I've set it up and then do some basic disk performance testing. This is the dashboard of FrankenNAS, and everything looks to be in order. TrueNAS properly detected the CPU model, RAM amount, and so on. Not that I didn't think it wouldn't, I'm just jazzed that everything has worked to this point. If we swing over to storage on the left, we can see the single storage pool I've created called FrankenPool. Yes, the jokes write themselves sometimes, don't they? If we click on Manage Devices, we can see that I created a single RAID Z1 pool of 6 disks in the array, all of them happy and healthy. And I've added the single 1TB NVMe that comes with the system as a read cache since I didn't know what to do with it, honestly. All good, moving on. Over in Datasets, I created a single dataset called FrankenSet inside of FrankenPool. And clicking on it shows everything is functional as expected. And lastly, if we swing over to shares, we can see that I've created an SMB share and an NFS share that point back to FrankenSet. Now let's do some on-device storage performance testing, shall we? To do this, we'll head over to System, and then to Shell to get to the shell of FrankenNAS. We'll be using FIO to do our disk performance testing. The first command we'll run will be a random read test against FrankenPool using 4 threads with a file size of 1 GB and an I/O depth of 16. Here's the command if you want to try this yourself at home. And go. And the results were an average of 582 megabytes a second in random read testing. Good, not great, but good. Now let's run the test again, this time doing random writes only and see what sort of speeds we get. We'll be using the same command with some simple changes. And go. This time, the results of the random writes came in at an average of 321 megabytes a second. Again, good, but not mind-blowing. Now let's spice things up and do a set of sequential reads and writes. Here, I expect the magic of ZFS to kick in and caching to come into play with the benchmarking. Here's the sequential read command. And action. And as expected, we were greeted with an absolutely massive 7.68 gigabytes a second sequential read speed. Again, this isn't a real number. It's a magical ZFS cache-infused number. And I say this not because I don't think ZFS is awesome or anything. It's just that it's impossible to get more than around 3.3 gigabytes a second out of 6 SATA 3 connected SSDs. So yeah. So finally, let's see what the sequential write performance looks like even though we know the numbers are fantasy. Here's the command, and go. Sequential writes came in a bit slower at 4.45 gigabytes a second, so cool. Okay, we've gone from planning to purchase, to build to testing. All that's left to do now is design and build this cursed NAS a 3D printed enclosure as jank as the build itself. Full disclosure here, this is not my best work. I don't believe for an instant this enclosure will survive much beyond this video. And knowing how hot the RAID card gets, I'm gonna need to have active cooling in the case, or I'm gonna have a puddle of melted plastic. Let's take a look at the design. Here's what I've come up with. It's an incredibly basic design that stacks the NAV9 Plus on top of the disk array, centers them in the middle of the front, has perforations on the left side for airflow for the RAID card, and on the right has the opening for mounting the SFX PSU. On the left side of the box, there's more ventilation because, again, I'm afraid that the hot RAID card is going to liquefy the plastic housing I'm creating if I don't. On the right side of the box is a giant cutout for the SFX PSU fan to easily ventilate itself. I could have created a perforated side panel for the PSU fan, but I like the idea of the PSU fan being unrestricted. Inside the box is clear and open, and I have a really novel idea for how to mount the disk array and OcuLink to PCIe card without them moving around, which I'll show you in a bit. And around the back, I've added a giant 120mm fan mount because I really want to pull air through this case to keep all the components cool, and I've also designed a simple 4-port Keystone jack insert so I can pass the NAV9 Plus's ports through to the back of the case. We'll take a look at that in a moment too. So let's look at how all of these walls are going to come together and actually stay together. These are the same walls you just saw as a complete 3D structure laid flat with tabs around the edges of each piece. Those tabs align with the sides adjacent to each other, and when all these pieces are printed out, I'll slot them together and use some incredibly strong 3D printing glue to bond those sides together permanently. Oh, and hey, when they're all laid out like this, it kind of looks like a wee little robot, doesn't it? Off camera, I printed all the pieces and permanently bonded the bottom, front, back, and sides together, and now it's time to figure out how I'm going to get everything permanently affixed into place. I don't want to use epoxy or hot glue to secure these components because it's messy, looks gross, and it's permanent. And someday I might want to reuse these parts in other builds, as is tradition. So, I'm going to step up my personal game with plastic insets, which is what the professionals use. But before we get to that, I need to do some surgery on the disk array. You know, the Chenbro array is really perfect for this, but it comes with this additional little flange here that obviously is for mounting it into whatever it's supposed to go into. But you can see it's only affixed by these two little rivets. So I think I'm going to drill those out. That way this part just goes away and we just have the array. It makes it easier for me to mount inside of my 3D printed case. To do that, I'm going to take off the controller board on the back side though, because I really don't want any metal shavings to get anywhere into any of those ports. And it's pretty easy. It looks like it's just 2 screws. And then I think it just slides back like that actually. Okay, so now we just have the metal box. This is the controller board with the SAS SATA ports on it. And I'm gonna take this guy down to the garage and drill those out. And just like that, boop, it's gone. So that was the part. Now it's completely clear. We can put the controller back on it now, because that's what we need to do. If I can do this without screwing it up again. Now, back to the way it was before. Cool. I mentioned airflow for this case earlier. I am genuinely concerned about the heat the RAID card gives off. So as I mentioned previously, I've added a 120mm fan to Franken NAS's case. And to protect that fan from getting cables stuffed into the blades, I 3D printed a fan grill for the intake side of the fan. This way, I know that when I ultimately stuff a giant mess of cables into this case, they won't stop the fan from spinning. Now I'll mount the completed fan assembly into the back of the box, and we're good to go. For the PSU, I marked holes on the front of the case that correspond with the mounting holes in the power supply, cautiously drilled holes through the front to pass screws through to the PSU, and then permanently affixed the PSU with screws to the case. Now let's tackle mounting holes for the disk array and the PCIe card. My first step was to mark the spots that I needed to drill holes into the case for the mounting locations for everything and drill the holes through. Here's where those awesome little plastic insets come into play. The holes I drilled are just slightly smaller than the insets themselves, and to place them, I use a soldering iron with a special tip inserted that allows me to press the insets into the hole, melting the sides around the inset. When this cools, the inset is basically permanently set in the plastic. And that's because the insets have little knurls around its sides that the plastic melts into, giving it some teeth to stay put after it cools. This isn't an easy process, and it was the first time I'd ever done this, and I kinda screwed up on one, but not enough to be a problem. Just looks pretty janky. Now that the insets have cooled down, I'll add the retention screws for the keyhole mounting in the disc array, and then I'll drop in the disc array and slide it forward to mount it in place. This isn't going to be enough to keep it from sliding back into the case though, so for that, I added another screw mount at the back of the array to prevent the array from sliding backwards. The next physical thing to mount is the OcuLink to PCIe card. The board itself helpfully comes with mounting holes on all 4 corners, and I only need 2 of these to keep it in place. So after screwing in both the top and the bottom of the right side, we now have that affixed. Lastly, let's talk about the I/O port block on the back. Once I added the keystones to the 3D printed port block, it easily inserts into the opening in the back of the case. I will admit though, I did cheat here. I used my 3D printing glue to bond the block to the back of the case, which I feel totally fine with because I don't ever want it to pop out, especially when plugging things into it. You might be wondering how I'm going to mount the Nav9 Plus into FrankenNAS and keep it from moving around as well, since it's sitting on top of the array. This was quite an engineering challenge for me. I didn't want to do anything to permanently affix the Nav9 Plus to anything because if I need to access the physical ports on the back or pull it out of the case to work on it, I didn't want to have to disassemble the whole thing. And that's where I came up with this. This 3D printed piece wraps around the Nav9 Plus, effectively capturing it and preventing it from moving anywhere, and is mounted to the front and back of the case itself, which has the added benefit of providing additional rigidity to the case. The funny thing is, this really wasn't my intention when I was designing it. It just ended up being a happy accident that really helped strengthen the case at the same time. Now it's time to cable it all together for the last time, close it up, and see if it powers on. I did it. I did it. I built this thing start to finish all in my head, and now it's time to power it on to see if it actually works, because it's built, and it's ready to go. I can't wait. Let's do it. Oh my gosh, so good to go.
It's working!
Oh my gosh. It's alive! Here it is, folks. FrankenNAS in the flesh. What started out as a fleeting comment has culminated in the first ever from the ground up NAS build I've ever undertaken. It has been a hell of a journey. This was so much fun, and honestly, I feel like I needed it. It ended up being one of those ADHD black hole moments where I just lost track of time and poured every spare moment I had into it. I just love projects like this, and if I'm being honest, I'm proud of myself. This one worked out. On a more serious note, I'm here from the future to tell you that OcuLink ports need to be standard connections on all systems. The flexibility it provides is really fantastic. You can hang an external GPU, RAID card, NIC, or whatever you want off of it. The possibilities are endless. Would I recommend you try something like this at home? Hell yes. Get yourself a 3D printer, get yourself into Tinkercad, start creating, and then join our Discord community and share your creations so I can see all the cool stuff that you've created. One last thing before I close out this video, there are a few people I want to thank for the help along the way. Brandon for the encouragement, Sakura for help getting the RAID card into IT mode on a mini PC that didn't support accessing the card's BIOS add-in utility, and also the rest of the community for listening to me blather on about FrankenNAS for the past 2 weeks. Catch you guys all in the next video.